Today we're going to finish up our enclosure build. This is Automated 3D Printing Enclosure Part 2. Hello everyone, Chris here. I hope you're all well, and it has been a while since we did Part 1 of our enclosure build. And the goal here was to try to automate as many features on this enclosure that we could using OctoPrint. And we've done a lot of work, but we have a lot more work to go. So let's start with this one by recapping what we did in the last video. So here's a look inside the enclosure. We added our webcam. It's routed directly over to the Raspberry Pi on the other side. We'll take a look at that in a second. Down there in the corner, we have an active heater. It's forcing heat up. We have a light up here on top. You can't see it, but it's just screwed to the top of this enclosure. We used double-sided tape in the first video, but I don't suggest that. As soon as these start to warm up, that tape fails. So that was good to know. We also have a one-wire temperature sensor up here in the corner so that OctoPrint knows what temperature it is inside the enclosure. And the heater is directly wired to a thermostat right here. Just in case something bad happens, something happens in OctoPrint, something gets stuck on, this thermostat won't allow it to go over a certain temperature. And if you saw in the last video when we did the testing, I don't want to get over 45°C in here. That's more than enough for the plastic that I want to use. And I am going to use a Prusa printer, which has PETG parts on it. So 45 should be the limit. But just so I can get to there, I have hard set this thermostat to 50. And here's the side of the enclosure with all the wiring we have so far. We have a port over here for our BOFA filter. We're going to talk about that. We've got some power down here. We've got 12 volt coming into this barrel connector that powers these strips. And then we can run power from here to other parts that we want to use. We've got 12 volt from over here that goes to the buck converter that goes to our Raspberry Pi to power it up, so that's good. We've got our sensor wires coming in on our Raspberry Pi header. We did add that on. Makes it a lot easier to use the Pi. And we've got our wires for our light up here at the top. I just wired it direct, so anytime you turn the enclosure on, it comes on. But we might want to change that up as well. So like I said, we're off to a good start. We've got more light. We've got a Raspberry Pi running OctoPrint. We can already get an active temperature in OctoPrint with that sensor of the enclosure, so we can monitor it. That's good. But we need to go even further. That includes filtration, being able to pull air out of the enclosure if we need to, and a few other features that I'd like to add. So we're just going to step through this one feature at a time. I'll show you how I'm going to connect it up to be able to control it with the GPIO on the Raspberry Pi. So let's circle back just a little bit and talk about the light in the enclosure. So in the last video, all we did was add an LED strip light up here on top. It's very simple, but I just ran the wire through the enclosure and I plugged it directly into 12 volt. So I thought that that would be a good place to start here. It would be nice to be able to turn that light on or off via OctoPrint, maybe when the print starts, when the print stops, whatever we want to do. So the easiest way to do that would be to add a relay. And adding a relay to this configuration is going to allow us to do a lot of different things. And here's the relay we're going to use. It's just a simple 5 volt relay. There are 2 of them on here, so we can control 2 different devices. I'm planning on doing the light and then maybe an evacuation fan on the other side, but we'll see how that goes. So we need to start by getting this set up. These do operate either high or low, whichever you want to trigger. You have the power for the relay right in here, as well as the pin that you want to use for GPIO, the control pin, and then your outputs over here. I have this 3D printed case. It's just got some holes in the back so we can screw it down to the enclosure so that it doesn't contact the metal on the outside of that ACM. So we'll just start by mounting our relay up. I've got a couple of holes to match my 3D printed mount. I'm using some countersunk screws so they don't contact any of the parts on that relay. And we'll just mount it here on the side of the enclosure. I'm using M3 nylock nuts on the back. And when you're mounting stuff on this enclosure, just a side tip, these are made so that you can move their spool holder design to whichever side or the back if you want to. Mine's on the top. But I just removed this one from the back so I can get my arm in there to tie down these different mounts so I can get the nuts on the back of the screws. Just a side tip. It can be kind of a pain going through the front door all the time. And with that plate on, then your relay can just mount in there. You should be able to just thread that screw into the plastic to hold it. That's how I designed it. A couple of screws are going to hold it in place just fine. So now that it's mounted, let's start by powering up the relay. Again, I'm going to leave the jumper so that these trigger when it goes high, because that's how I'm going to configure this GPIO. You'll see that in OctoPrint, but we do need 5 volt for this module. So I'm just going to use some jumpers and wire this up to the GPIO. I'm going to take the 5 volt pin all the way down here, and that goes on the VCC pin here on the relay. And we'll use one of the ground pins. That's on the other side of this header, at least for this relay. So we'll go to ground. And then we can pick whichever GPIO pin we want. For this one, let's just go all the way to the end here for fun. That is labeled GPIO 21. Make sure you're using the 21 number, the GPIO number, when you're using your schematic, because a couple of different pin numbers can be used. The GPIO number, that's the one that's going to be used inside Linux, that Raspbian. And remember, with this header that we got for the Raspberry Pi, the screws are tiny, so make sure you have a really tiny screwdriver for this. But let's just say that GPIO pin 21, that's going to do the first relay, so this one here up top. So we're going to put that one on the in pin 1, right there. So now we should be able to use these contacts over here for this relay. So from here, down here on our power distribution, we're going to go ahead and unhook the light. It's in this second spot down here. So we can use this now on the relay side, but we're still going to have 12 volt run to the relay to power things up. And everything that I want to power, we should really only need one feed. So I just made up another pigtail here. I'm going to hook that in the place where we remove the light on the power distribution block. I'm going to redo the light wire as well as our new feed. The positives, I'm going to put ferrules on them instead of spade connectors because we're going to use these terminals. And for the power feed, I'm going to use the normally closed side on the terminal here. You can either use normally open or normally closed. It doesn't really matter. You can configure how that works inside OctoPrint. So the 12 volt power in, I'm going to stick right here. And then the other side of the light, the positive lead, right in the middle. And for now, just to get us off and running, I'm going to take the grounds and just twist them together, because I'm going to want to add something else in here in a moment, and we'll make this more permanent when we're done. So at this point, let's go ahead and power up OctoPrint, power up the Pi, and give it a test to make sure we did it correctly. After the Raspberry Pi comes up and OctoPrint starts, those pins should be low by default. But when it first starts, when you power up the Pi, a lot of them are high, so be aware of that. That is one thing we don't want to get caught in if we're using something like a heater. Hence why I use the thermostat. But now the light is off. And back into OctoPrint, inside the Enclosure plugin that we started to set up in the last video, now we can just add outputs. Our only input is going to be that temperature sensor. We just care to react to things based on starts and stops of prints or what temperature it is in the enclosure. So we should have everything we need. But let's start by adding an output. So let's hit Add Outputs. We're going to do a regular I/O for this one, and most of the things we're going to add, because we're just turning on and off a light for this one. So let's call it light. And then our I/O number is that GPIO pin, and we went with 21. And you can set any of these options how you like. You can start it with the server, auto startup. There's options that you can make it react to your print. There's a timer, all kinds of good stuff in here. We want it to be active when the pin goes high. That's how we have it set up on our relay. So we're going to uncheck that one. That one's on by default. And let's go ahead and show the button on the nav bar, so we can kick it on whenever we want to. And let's save it. So here's the Enclosure plugin page. You can see our button, but it's also up here if we want to use it. So currently, light is off. Light is off in the enclosure. We'll turn light on. You can hear that relay trip. Light is on. Off. On. So there, we're on our way to automating a few things. I like it already. So you can kind of see where I'm going here. The light was a no-brainer, but any feature that we add, I want to be able to control it via OctoPrint and that Enclosure plugin. So we want them all to work together, and we could even use G-code or the features in OctoPrint to control them automatically. So that's what we're going to get to. But the next thing we need to deal with is filtration. If you have an enclosure, you probably want to print higher temp plastics. Some of those have some pretty nasty VOCs that you don't want to breathe in. And the best option would be to filter them out. And that's why we have this BOFA Print Pro One. So this is the Print Pro One. This is the low end of the BOFA filter range. It just doesn't have as many features as some of the other ones do, but it's still pretty pricey at $350. They're kind of noisy, and you can't recirculate air back into the enclosure, but it's definitely going to filter out anything that you might encounter inside one of these enclosures, especially at the lower end of high temp that we're going to be doing. But all this really is a fan on the bottom with a really fancy filter in between. That filter does have carbon in it, and it is replaceable. So it's a combination filter. It's very large. You can hear it. There's probably some charcoal floating around in there, but you've got the filter screen here on this side, and we're actually pulling air down through. And then you have the filter material on that side. It's got nice rubber sturdy seals on it, so you can ensure nothing is going to seep out. And in the box, it's pretty much just a fan. And the hose that it comes with, these were designed alongside printed solid to fit these enclosures. And this filter just happens to be 12 volt, which is the main reason that I use 12 volt for this enclosure build. And the draw on them shouldn't be that high, so we should be able to use our setup with it just fine. But there's a nice added feature on these, and that's this jack right here. There's a relay inside that you can power with, I believe it's 3 to 32 volts, but you can use that to kick this filter on and off as needed. So that's how we're going to add it to our setup. So back to the enclosure, I'm just going to add another set of wires here to power up the filter. The input power on this filter uses a pretty standard barrel type connector. I'll leave a link to these if you need to look it up. But we'll just add that straight to our rail here. So that one can just go straight into the filter. And then we have one of these types of barrel jacks that can go in here. Positive center. It'll go right in like this. And then all you need is some voltage to be able to turn this on and off. We're just going to use 5 volt from the Pi. So back to the Pi, we're just going to grab any one of the grounds that you find here, whichever one's convenient for you. And then pretty much basically any open GPIO pin, because they're going to go high 5 volts when we kick them on inside OctoPrint. Remember, it might come on high 5 volts, so the filter might start up when you boot up, but it won't run for very long. For no reason at all, let's just pick GPIO 24 for the positive. And let's take this one step at a time. Let's power it back up and get into OctoPrint. And we'll just set another output, just like we did for the light. So we'll go into Settings, Enclosure Plugin, and we'll add outputs. Again, regular I/O. We'll call this one Filter. And we went with GPIO 24. And set whichever options you'd like. We're going active high. So we'll uncheck that one, and we can show it on the nav bar. We'll hit save. There's our filter button. We should be able to kick it on, and you can hear our filter start up. And just a quick tip, I know that filter's loud, we'll turn it off here in a second, but if you're going to set it up with this connector where you're kicking it on via that internal relay, you want to make sure the power switch is down. If you flip it up, that'll actually turn it off. So, side tip. And to hook it into the safety enclosure, it's easy as a vacuum. You put one on here, and then one on your enclosure side. This is a downloadable port from Printed Solid. It's made for this enclosure. But we'll set that up here in a little bit. So now we can actively control our filter inside of OctoPrint. And you might be asking, why would I ever want to turn it off or turn it back on? We'll get to that in a moment. It does affect the temperature inside the enclosure a bit. But I'd also like to have a bit of a safety measure. I'd like to have just a regular old exhaust fan so that I could pull air out of the enclosure quickly in case something bad happened. Maybe the heater was running away, or our thermostat didn't work like it should have. We'll have a backup safety measure where we can cool it down. So I'd like to add a fan on the other side. And here's the fan we're going to use. It's just a regular old 60mm fan that I got off of Amazon. The draw is very low, and these enclosures come with screw holes that should mount up directly with this fan. I am going to put this fan on the inside so that I can pull air out. So I've got the fan installed on the other side. That's pretty self-explanatory. We'll take a look at it in a minute. The important part is the wiring. So I just pulled the wire for the fan through where the light came through. And this relay has 12-volt supply to it already. We don't want to have to run another one to do the fan as well. We're just using these relays as switches. So what I'm going to do is just make a jumper. The input voltage for both should go across both of these, and then we just use a different device on each one of the relay terminals. So I'm going to unhook this one, the one that we have for input currently, and I'm just going to clip off my ferrule that I put on here. And I'm just going to twist in a short piece of wire. And then on both those wires, I'll just put on another ferrule. And then on the other side of our short piece of wire, we'll put on another ferrule so that it goes over to our other relay. So back to our relay, we'll just put our input voltage back in here, and we'll just jumper over so we have input for our second relay. And then our new fan wire gets a ferrule on it, and it goes in the center terminal, just like we did for our light. And then all the ground wires can just go together. You can handle these however you wish. You could solder them, put some heat shrink on it, you could use a butt splice, however you want to do it, but they all need to go together. And at this point, I'm ready to make it permanent. And I just went the solder and heat shrink route. This will be just fine after we get all the wire management done. We'll have to tie all these down. But now we should be able to control our fan, as well as our light, same relay module. And now that we've got the power wired up, we just need another GPIO pin over on the Pi. So this one goes on N2 on the relay. And then pick, again, any GPIO pin you would like. Just make sure it's an I/O pin, of course, but let's go with 25. So let's boot up again, get back into OctoPrint. Before we do that, there's a look at the fan real quick. You can see I have the blade facing in, so it's pushing air out, just in case we need to evacuate the chamber if it gets too hot. So let's jump in and set up our new fan settings. Enclosure plugin. Add outputs. We're just going to do regular again. Let's call it ENC_fan, just so nobody gets confused. And we are on 25. And it is active high, and will show the button on the nav bar. Save. The fan turned off, we can turn it back on. The fan's on, and we'll turn it back off. So we're starting to get pretty fancy here with this enclosure. We can control all kinds of different things, but remember, we have a heater inside here. There is active heating, and I definitely want to be able to control that if I need to. Turn it on, turn it off, in case things get too high. So that's a job for something like an SSR. And here's the solid state relay that we're going with. This is a 25 amp relay. That heater isn't going to have near that much draw, but you definitely want something more substantial if you're creating heat. Those little relays just aren't going to be able to stand up to this. So you definitely want something more substantial. A lot of these are designed to be on a heat sink, but it's actually a pretty good fit on this enclosure because of that ACM. It goes right up next to it. And you can control these with 3 to 32 volts. So the Pi is going to be able to control it just like all of our other features. So this should be a good fit. So I just mounted the SSR on the back here down low where we have the power coming in and out. I actually mounted it upside down because I thought it would be easier to get to the Pi that's over here on this side to run those wires up to it. And this is the pigtail that we created for the heater in the last video. It just plugs straight in. And this SSR is just breaking the hot lead of that heater. So we just need to separate one of these, plug one into each side of our SSR. So I'm just going to separate this out. With our hot lead here, we're just going to leave the common lead in place. But the hot side, we're going to cut it. I shouldn't have to say this, but make sure this stuff's not plugged in. We've got the end stripped. Then we'll put on some new spade connectors. The side from the wall, I'm going to go put on this side. And then the side that actually runs over to our thermostat, I'm going to put on this side. Remember, we have that thermostat in line as well, just for extra safety. And then on the top side, we need some wires to run over to our Pi. So I just put some spade connectors on this, and we'll put our 5-volt there, and a ground right there. And when dealing with an SSR, remember, we're dealing with AC power. This could really hurt you or kill you. So be very careful and always remember to put your cover back on, just to give you a little bit of extra protection. And again, on the Raspberry Pi side, you can just pick another set of pins. I'm going to grab a ground because there's quite a few on this rail, so I don't need to put them together. But if you had to put them together, you could. I would just tie them to some sort of terminal strip, whatever you had to do. But there's quite a few ground pins. And just pick another GPIO pin. Let's go with the one right next to that ground I used, and we'll go with 12. And we should be able to control our heater now. And since we're talking about AC power, I thought it would be a nice add-on to put a power strip on the back of this, just so we could plug in our heater, the power control to the enclosure, and then just plug it all in at one time. Because we do have a couple of different things going here, so I thought that might be a nice add-on. I got this one that actually had some mounting holes, so I could just use screws, regular hardware, to put it on the back of the enclosure. So we'll go ahead and get that put on. So there, the power strip, that's going to make it a lot easier to add things if we need to, and to keep this stuff out of the way here in the back. Plus, you know, you could always use a few more outlets, right? But I used some of these 3D printed wire tie holders, just screwed them through the enclosure, zip tie some stuff down, and I plan on going around the whole enclosure later and putting a lot of these on, just to clean everything up. And before we go any further, I do want to stress one more time, if you're using AC voltage, mains power, be very, very careful. It can really hurt you. If you don't know what you're doing, please don't attempt a project like this, or at least get somebody to help you out. Just be careful out there. Now, we have most of the features installed. The exhaust fan, we've got our filter, we can control that, we can control our heater, we can control our light, but there's one thing that we've kind of left out. We don't have a 3D printer in here yet. So when you put your printer in an enclosure like this, you should probably keep the PSU outside of that enclosure. Everything else at the 45°C temperature that we're going for should be just fine. But those PSUs really don't like the heat. So let's find a good way to relocate our PSU on our 3D printer to somewhere on the outside of this unit. So the Prusa that I use in the enclosure has the Delta style power supply on it. It mounts up just a little bit differently than the old Chrome one, but we should be able to figure out a decently convenient way to put it on the outside of the enclosure. It has some pretty long wires on it already because it runs over to the other side of the printer to get in the control box. So let's just unhook it from the printer. It's these two screws here in the frame. And then on this side, we can go ahead and take our cover off. Then you can unhook your power off detect wire and then unscrew the terminals for your power. You can pull those loose, and then down here on the bottom, there's two more screws and some tabs that go into T-nuts. Back those out, and then we can pull it off. And it's free. Now you can just undo the zip ties or whatever you have down here holding your power cables, and we'll just flip them to rotate out the other side of the printer because we're going to put these out the left side of the enclosure. So I'm going to mount the PSU outside over here on the left. It's going to go right here. I've got a hole down here to pull the wires through. I didn't want to mess with the threads on the back here. You could thread something in. These two down here are actually for the cover. So I'm just going to use these two groove mounts like they do on the Mark III. And then I made this plastic bracket so that I could use one of these side holes. You could do two if you'd like. That is an M4x10 if you want to use these. I'll share these files. But that allows it to set right up against the side there. That should be a good location. The only drawback is that you have your plug here facing the front because these were intended to go on the right side of the machine. But it shouldn't be that big of a deal. We can plug it in and kind of route it to the back. So I'll go ahead and get that installed. So there we go, all mounted up. Now we can go ahead and put the printer in and run the wires out and hook it up. We're just about done. We need to do some testing. I had kicked around the idea of putting some rubber feet on this enclosure, so I think I'll try to make some. And here's what I came up with. I just made these out of Ninja Flex. They're pretty squishy, but they're just going to go around the edges of that ACM. You can set them down in there, and there's a hole so that you can screw them to the bottom. Now I did make a center foot as well. Because that ACM isn't very thick, if you have it elevated at all, I worry about it sagging, so I'm going to put this one right in the middle of the bottom piece. So it just has a little support in the middle to hold that printer up. So there we go, feet on. It does isolate it from the tabletop, so that's probably a good thing. It might make it a little less noisy. And you can see that screw head here, the nylock nut, I put it through the bottom. I feel better that it has support there in the center when the printer is going to be setting on it. It shouldn't interfere with the printer at all. But now it is time to go ahead and put the printer in. With our camera mount and everything, it is a little bit of a tight fit. You can take the camera out or just flip it up a little bit. You can still get it in there, just be careful. And we can go ahead and run those wires to the outside and put them on our PSU. We've got the wires ran back through, we've got our power loss cable back on, we'll put our cover back on, and then I can go ahead and run a plug around the side. Again, that's not ideal because it's in the front, but it shouldn't matter that much after we get it all tied down. So everything that I wanted to do for this enclosure is complete. I've got the filter set up, all the power is done, all the features have been implemented. Now we need to do some testing. Why you might want an enclosure, we'll run through a scenario like that, as well as how all the features are going to work, and I'll show you how I'm going to set up all the automation. So one thing I wanted to mention, I didn't state how this printer was connected to that Raspberry Pi 3B. I'm not using GPIO, I'm just using the USB cable from my controller over there all the way around to the Pi. That should be pretty obvious. I just wanted to make sure you knew that's how I was connecting up to the printer. So basically the enclosure build project is done. We've got everything added onto it, but now we have to configure the software to make it fully automated. And we'll get to that in a moment. But first, I wanted to show you why we're doing this whole thing in the first place, how the enclosure actually impacts the print quality, and show you some FLIR footage of the temperature changing inside based on certain scenarios, with everything turned off, with it just the heater on, and then fully automated with this filter, because some of these features are going to alter how the heat changes inside here during your print. Now before we get started, let's go ahead and take some baselines real quick. So I just booted up the whole enclosure, Raspberry Pi OctoPrint has started. But let's have a look at FLIR real quick at what it looks like right now. You can see that thermometer over there. It's probably hard to see, but it does say 19°C at the moment. So here's a look at the enclosure baseline. You notice a few hot spots around here. Right here, this one where you can see my hand, that is the webcam. Down here, that's actually the SSR on the back side of the enclosure. Those things do get really warm. We'll look at that further. But the heat that you can see deflecting onto the top up here is more than likely caused by that SSR. And I've just got a few points around the enclosure where we can take a few different temps. I've got one outside over there, that cold spot at 17.5°C. Note the holding currents on those Z motors. You can see them glowing there at the bottom. That's what's going on with those. So now I'm going to kick the heater on so that you can see the heat come in as it warms up. The heater is somewhere located right around the bottom of that webcam. The heater just kicked on. We'll wait for it to warm up. Pretty much instantly you can see the top of that ACM start to warm up. And here's the enclosure after the heater has run for a couple of minutes. You can see where our hotspots are. Of course, the top of that ACM where that heater is firing the heat into, we're around 52°C. And you can see there's a lot of cold spots down around the bottom of the enclosure. You can see the thermometer down here on the floor is setting around 19.5°C. The internal thermometer we have fed into our Pi is setting around 35, 36. And the one on the outside of the enclosure is setting around 32. So we have some mixed results. But my biggest concern is that when we turn on our filter, it actually pulls heat out of the enclosure. And that's what we need to combat. So let me just turn on the filter and you can see the difference. I just turned the filter on. Watch the changes. So you can see in the center of the enclosure, it's pulling the temp down quite a bit, and it will continue to pull it down as it runs. So we need to do something about that as far as our automation goes, but it really makes a lot of difference when the printer's running. So we need to take a look at that next. And here's a look at the enclosure after the print's been running for almost 30 minutes. You can see how the temperature has changed. Of course, the bed is going to be the hottest, but also the floor temperature is rising. So basically, the longer the print runs, the higher the floor temp goes. It is falling right now because I have the door open, but the printer is heating it from the bottom up because that bed is pretty hot. It's currently running at 110°C for ABS, and then that heater is heating the air on top of the enclosure. So you should get a pretty consistent mix. And when the temperature is up to temp for ABS like it is right now, the biggest concern is when that filter kicks on, how much it cools down. So let's go ahead and turn it on. So you can see after a couple of minutes of that filter running, it's definitely pulling the temperature down. So we need to compensate for that when we do our automation. And just for fun, let's go ahead and kick on that evacuation fan just to see how far it will drop down then. The fan is on. Remember, it's kicking air out the side of the enclosure. You can see that left side there get a whole lot cooler. It just continues to expand into the center of the enclosure. So it's definitely doing its job, cooling everything off. We only want to use this in case of emergency. So with that footage, you can see what we're trying to combat here. We definitely want to filter the enclosure because that's just the right thing to do. We want to avoid those VOCs. But this filter, the lower end, is just pulling the air out with a fan. It's not recirculating it back in, so you can keep that warm air. So it's going to effectively pull the temperature down in your enclosure. But with the right automation, with that heater, the filter, we can oscillate it on and off, and that fan, just in case of emergencies, we should be able to set up the enclosure plugin to get all that done. So let's do that now. So for the sake of this video, I just went in and deleted all the outputs that we made for testing before. So we can set these up in order so I can show you how it's going to work from now on. So the first thing, again, we're just going to add an output. Remember your GPIO pins. The first one I want to add is a heater. So temperature, humidity control. All of these have a few different attributes. Check them out. Whatever meets your use case, go with that one. But we're just going to label this one heater. Our heater was on GPIO pin 12. We are going to auto start the heater when the print starts, because we know if we're printing in the enclosure, we probably want heat. If you're not printing high temp, you want to go another route, you might not want to set it up this way. But I'm focused just on ABS, ASA, filaments like that. And we're going to auto shut down. We want to make sure that heater goes off when the print completes. We also want to make sure we shut down on failed or canceled prints. You don't want to come in here, cancel a print, and then that heater's still running for some reason. You want to make sure that it's going to go down in case something bad happens to the print. We will auto shut down in case of serial error as well. Now remember, on our enclosure, we went everything active high. Those relays are triggered all the time. Now, I probably ought to mention something here. You might want to mix this up in your install. The way we set these up, I had you hook the wires up normally closed in those terminals for the relay. And you can see this LED is on. That means that this relay is triggered all the time because it has it closed. Depending on the state that you run in the most, I don't know that it's going to matter a whole lot, if you have to actually wear this relay out, but you might want to go one way or the other. If your enclosure sets dormant most of the time, you're not running a lot of prints, you might want to switch to normally open, so this isn't constantly triggered. Or on the other side of things, if you use it a lot, leave it in normally closed, because that way the relay is not actually going to be triggered while the printer's running. Just keep that in mind. I don't know if it really matters a whole lot on wear and tear. I just wanted to mention it. You can set it up however you like. Back to OctoPrint. We want the temperature sensor. That's the only thing we didn't remove. That's what we're going off of for our heater. We want to set our default value. Let's shoot for 45. And the way this works for the heater, it's going to try to get to 45, and it's going to oscillate it for you. So it's going to turn on at print start, get all the way up to the defined temperature, and then shut off if it goes over. And you can also do some deadband down here. If you would like to allow it to float 2 degrees either way before it acts, something like that, you could do that here. So let's go ahead and give it 2. So it's possible that we could get up to 47. That's on the high range of what I'm comfortable at, but it should float within there. Remember, this is the temperature sensor, the temperature it's going off of. Down at the printer, it's not necessarily going to be near this high. We just want to keep it consistent. And then your max temp, this is where the heater will completely shut off and it will not resume until you reset that temperature. I'm going to set that at 50. And I'll show you that on the other screen more. It just means that you have to intervene before it'll continue heating. So that's good for the heater. Let's add another one. This one we're going to add the filter as a regular I/O device. So let's just call this filter. Our filter was on GPIO 24. I'm going to start it with the server. I'm going to auto start when the print starts, but I'm going to put a delay. So on ABS temps inside this enclosure with this Prusa, it gets up to printer temperature when it starts the print in about 7 minutes. But it takes the internal temperature of the enclosure to get to about 42. It takes about 15 minutes. So I'm going to delay the start of the filter so the enclosure has time to get up to temp. So you have to do it in seconds, so we're just going to do 900. That's 15 minutes. I want it to auto shut down when the printer stops. Shut down for failed or canceled. Auto shut down, serial connection error, and it is active high. So we'll uncheck that one. So we're good for filter. We'll add another one. Regular I/O, let's just add one for the light. It was on 21. And I'm going to do auto startup for print. It doesn't really matter to me, but we just won't let it run all the time. And we'll shut it off when the print is finished. Same, it will shut it off if we cancel. And auto shut down on serial connection errors. And it is also active high. That one's not so crucial. You can set it up however you want. We'll add another one. And we'll add one for our fan. Let's call it fan. We're on GPIO 25. And we don't want to do anything with this one. We just want to be able to kick it on if we happen to need it. So only thing that I'm going to set here is I'm going to change this to active high because that's how it runs. So that's good. But now we need some temperature sensor control. So let's add some more outputs. Let's do an easy one first for that fan, temperature alarm. So when the temperature gets to a certain temp, I want action to happen. So if we get up to 50, that heater control that we already configured, it's going to stop the heater automatically and not restart it. But I'm going to go ahead and have the fan kick on and we're just going to bail out. If it gets to 50, something bad happened, it ran too long. I want the fan to come in and cool everything down so nothing bad happens to the printer. So we're going to control the fan and we're going to set it to high. So when it gets to 50, fan comes on full blast, cools the enclosure down, and hopefully it helps us avoid catastrophe. Or at least melting some of your printed parts. And that's pretty much all I want to add to this. The heater is going to take care of itself. Remember, it oscillates on and off. When the filter comes on, the enclosure should already be up to temp, so we can run it full blast. It is going to reduce the temp in the enclosure, but then the heater can compensate for that. And you'll see it kind of levels out. I'll show you some prints of it in operation. Now, what would be nice is if you had an output here, maybe something inside temperature humidity control. There is an option for a cooler, but there's no temperature for the cooler. It would be nice if they had one maybe labeled filter, because it does kind of cool the enclosure down. So you could set a temp, like a low temp, say 39°C. I'm going to turn the filter off for a little bit, let it get back up to temp, and then turn the filter back on. The developer of this plugin is looking for help from the community, by the way. So if you're a developer, you like OctoPrint and these plugins, you might consider helping them out, maybe add a feature like this for us. But for right now, this should be more than enough to get us where we need to be. So I'll just remove this one that I did as an example, and we will save. And here are all of our controls. Everything should be off because there's no print running. So let's go ahead and trial this automation out. We'll just go ahead and kick off a print. The light came on. The heater started. You can see that in OctoPrint, it set it to 45. If you were to hit that max temp of 50, this is where you'd come in to reset it. This would be set to off, but you would have to manually intervene to get it to come back on. And you can see the light down here is on. Now we're in that 15-minute wait right now for the filter. The printer does take, again, about 7 minutes to get fully up to temp. So that'll take a moment, but that'll be out of that 15-minute block as well. So the enclosure should be well up to temp before the filter kicks on. So we hit our 15-minute mark. You can hear that filter running. We made it up to 43 C in the enclosure within that time limit. So that's pretty good. Our target temperature is only 45. But you're going to see that temperature pull down some, even here in OctoPrint, because that filter is on. It took just a little bit over a minute, but you can see we lost half a degree. But remember, the heater is going to keep heating up until that 45 mark. Now, when it gets there and shuts the heater off, it does reduce pretty quickly, but the heater will kick right back on. And the longer that the printer runs, the more the printer is heating the enclosure. So that's going to compensate for it as well. So this is a pretty good setup, so you can allow that filter to run all the time. Just a little bit more FLIR for you. You can hear the filter is on. The internal temp says it's 42 on that sensor. You can see it's a little bit cooler, and the floor temperature reads at 27 C. But then we'll let it run for a while. So the print's been running for almost an hour and a half, and I have yet to hit that 45-degree target temperature. When the filter comes on, it does cool down the enclosure, and 42 C, 42 and a half is about all I can get. Now the print with ABS, it's going to turn out just fine at this temp, but I would like to be able to get to that target temperature if I wanted to. So I might change things up just a bit. You can see the floor temp is setting at about a 31 inside the enclosure, and I think if the print went even longer, it would increase, and that might alter the enclosure temperature. We might be able to get over that 42 and a half that we're seeing. So longer prints, it might impact it differently. But I think what I want to try is, you see that orange inlet right there? That's where our filter is currently located, right over our heater. The fan is over on the other port over there. So I think what I'm going to do is switch that fan with this port and move the filter to the other side, just to see how it impacts the enclosure temperature overall. So we flip the filter and the fan. The filter's over on that side now, and I already like this better than before. It's not directly pulling the air right over that heater, so it should keep it warmer. We're only 30 minutes into the print, and we're already at 43 and a half. 45 is our target. So again, much improved over the last setup. Our floor temp right now, 30 minutes, is only 29.2, and that's going to increase. So we should be able to get to that 45 in this 2-hour-ish print, no problem. So moving it is probably the way to go. So now a couple of time-lapse videos. This first one, no heat, no automation, with the enclosure door open. The second one is no heat, no automation, with the enclosure door closed. So just the heat from the printer. And the third one is with all of our automation running, the heat, the filter, the works, just as we set it up in OctoPrint. And here's the results. This is the one with the door open. You can see how it split. It split so bad I actually pulled it apart, getting it off the build plate. Here's the one with just the door closed, just the heat from the printer. The edges on the bottom did pull a little bit. You can see it a little bit more on the back side. You can see that ring right down in here. It did a fine job, no active heat at all. But with no active heat, you probably can't use that filter successfully because it does pull the temperature down. And here's the one with the automation. The heater, the filter, everything running. There's a little bit of inconsistency in there. It's the best print by far. A little better than the one with just the printer running. But remember also, the taller the print that you make, the more that heater is going to help. The further away from that build plate, the more chances you're going to have for it to cool down and start to split because of the shrinkage. And just to give you a little better idea of what the enclosure looks like while it's operating, here's some FLIR footage. This is with no heater, no filter, just the printer heat. I see the floor of the enclosure get to around 35 C during this 2-hour print, and the top of the enclosure around 37 C. The internal sensor reads about 40. And here's a look at the FLIR footage with the automation running, the filter and the heater. The print's been running for around 40 minutes now. The floor temp is at 33.6, outside enclosure temp right at 40, and then the sensor is hovering from 43.5 all the way up to 45. So I'm pretty happy with the setup overall. Just wanted you to see the comparison in between just the printer running and all the automation running. So there we go, our fully automated enclosure build is now complete. And just a few thoughts before we end. If you're going to do a project with a Raspberry Pi using GPIO pins, you want to make sure you have the proper safety precautions in place. Like that thermostat is a great place to start. Because I've seen on a lot of projects, including this one, those GPIO pins get in a state that you don't intend them to be in. And that could leave something like one of these heaters running continuously when you didn't think it should have been. So be mindful of that. Also, why you're using an enclosure in the first place. It's not about keeping all the heat in possible. It's about keeping it consistent inside. Also, using something like a filter to keep you safe from anything that might be in that filament that isn't good for you to breathe. And Printed Solid builds these enclosures with that in mind. There's lots of slots to keep the circulation going, so your printer won't melt down, especially if it has 3D printed parts on it. So, that will be it for today. I hope you enjoyed this series, and I will see you really soon on the next one.